Hello and welcome everybody. This presentation is about to begin. Today's presentation is on comprehensive steel design in LUSAS version 16, the new version which has recently been released. I'd like to introduce you to us as presenters. It's myself, Philip Ike, and my colleague, Julian Moses. We are as ever ably supported by Paul Belchamber, who will be answering questions. If you have a question to pose, please put it into the webinar panel. We'll try to get back to you during the event. Otherwise, we'll get back to you as soon as we can afterwards. If you want to see the webinar afterwards, there will be a recording made available, and we would encourage you to share that with your colleagues who couldn't make it today. So LUSAS version 16 is now 2 months old in the marketplace, and we'd like to talk briefly about why we built it and what that means for you as engineers. So the three main thrusts of the program are simplification. This was largely the subject of the first webinar. Increased efficiency, speed of use, better visualization, and better report generation. Collaborate, the ability to share information, whether that's through BIM standard platforms using the IFC format, or whether you want to share information between LUSAS teams by merging and separating models. And finally, design, the subject obviously of today's presentation. We've extended both the concrete and the steel side of design. The steel is completely new and heralds a new technology for us in comprehensive design output. So let's just talk a little bit about that. Steelwork Designer was newly released in version 16. It gives you a transparent understanding of calculations. In other words, you can see every clause, every formula, substitution, every answer, and references back to the code that help you as an engineer understand the process that we've gone through to deliver the calculations, and also help share it with others. It gets you away from the more typical black box approach of design calculations, and it's a methodology that we want to take forwards into other sectional design with future releases. The product itself is both flexible and familiar, so existing users will recognize easily how to work with it. It also uses many of the more important codes already globally, so we have the US, Canadian, European, Australian codes, and those are being added to all the time. This is a new design module option. We're running an offer on it until the end of March, and that's a 50% reduction on fees. So for those of you that like what you see today, please contact us and we'll talk to you about how we can upgrade you. So the presentations today, we split them in three. We're going to start off with building frame modeling. This harks back a little bit to the previous webinar. It's about speed, efficiency in building a model. This model, of course, being a beam structure, where the previous one was surface or plate structure modeling. In the second presentation, we're going to talk about collaborating, in other words, doing different parts of models with different teams and then joining those laterally, moving on to some of the nuances of loading and more advanced geometrical modeling. And finally, we get to the nub of today's presentation, the steel design. We're doing this to the building codes today. Obviously, the process is the same for bridge codes, and it's the same for the other international codes as well. So presentation number one, we're going to show you the building of the first story of a steel building frame. And at this point, I'm going to hand over to Julian. Over to you, Julian.
Okay, thanks, Phil. Hopefully you can see my screen. Now, before I get going on this, I do want to apologise. I've got a bit of a cold, so if I stop talking or I cough, I do apologise. Now, in this session, what we're going to do is look at basic geometry building, And we're going to do this using some layout grids. So I'm going to go to Utilities, Layout Grid. I'm going to have an origin at 0, rotation angle at 0, and in the X direction I want 9 lines. Now the spacing on these are going to be 8, 8, 8, 5, 5, 8, 8, 8. In the Y direction I'm going to have 5 lines, and I'm going to have a uniform spacing of 6 meters. I'm going to rename this Layout Grid Level 0. And I'm then going to OK this. You'll see the layout grid on the screen. I'm just going to resize that. And you can see the spacings, 6 meters in the Y direction, 8 meters in the X, then 5, and then 8 again. Now over here, I'm going to copy this layout grid, and I'm going to copy it in the Z direction by 6 meters. I'm then going to rename this layout grid to be Layout Grid Level 6 meters. Now if I rotate this, you'll see 2 layout grids, one above the other, and I'm going to use some of the tools to automatically create the column members between the grids. So if I go to the line by grid, multi-vertical, I'm going to drag the tool around this area, look at the isometric, and you can see the columns in that area. I'm going to repeat that here. I'm going to pick these 2 locations, this location and this location. So these are all the columns that we're going to use for the building. I'm going to switch off the visualization of layout grid 0. Now in these areas I need to create some beams. Now I'm actually going to do this by creating some surfaces. Now those surfaces are going to be used for floor loading. So surface by grid, multi-horizontal. So I'm going to drag around here and you can see I've created some surfaces. I'm going to repeat that in these areas. Now Phil is going to explain more about the surface loading later on. Now once I've created those surfaces, in these areas I need some surfaces, but I need to create some horizontal line members first of all. So I'm going to look back on plan, go back to line by grid, multi-horizontal, and I'm going to create some lines through here, down through there, and down through there. Now here I want to create a horizontal line, but I don't want it to be split at this location. So I'm going to go back to the multi-horizontal tool, but before I use it, I'm going to go to the settings, and I'm going to create one feature per drag on the grid. So I can create a line here now that isn't split. I'm going to do the same here and here. Finally, these 2 lines there. Okay, so I've finished using the grids now, so I'm going to switch the grids off, and I'm going to take some lines, these ones here, and I'm going to split them. So geometry line by splitting, and I'm going to split all of the lines into 2. Now the reason I'm doing this is I can now select this point to this point here, back down to there, and create some lines that represent some bracing. I'm going to repeat that in this area. Now rather than having a concrete core to this building, I'm going to have a braced steel core. So that's why I'm creating these lines here. You can see them there. Okay, now I've created those lines, I can fill in the rest of the surfaces. So I'm going to select the lines. I'm selecting these lines in an anti-clockwise direction. Once I've selected them, I hit the surface button and you'll see the surface appear on the screen. I just need to repeat that in a number of locations. So here on this side, again, just select the lines anti-clockwise. And finally at this location here. Once I've selected the lines, hit the surface button. Okay, now at the front of the building here, I need to create a couple of extra lines. So I'm going to take this point and this point, create a line. This point and this point, create a line. And finally, I can turn these into surfaces. So select these 3 lines, hit the surface button. Select these lines, hit the surface button. And finally, these lines and hit the surface button. Okay, so I've created the basic geometry that we're going to be working with for this frame member. Now in the second session, I'm going to look at putting the engineering properties on these. But for the moment, I'm going to hand back to Phil.
Okay, thank you, Julian. So moving forwards from creating this base geometry then, let's talk about some other elements of the new release. So one side, as I mentioned earlier on, is collaboration. And the buzzword for this, obviously, in the industry at the moment is BIM, building information or bridge information modeling. So LUSAS 16 sees the release of the IFC common file format that allows us to interface with other systems that allow the import and export of the same. You can also, within LUSAS, break your projects down and spread them around your teams using a utility called Model Merge. So for instance, you can have one engineer working on one side of the building, one on another, or top and bottom in this case, and then laterally merge the two parts of the model together. We're also obviously looking at a steel frame here. Julian mentioned earlier on that the floors that he'd put in were non-structural. So that is to say, we want to use those floors to load. We don't want them to be part of the structural, the mathematical model. So in order to do this, we have a utility that came out in version 15. It allows you to look at many different loading options, including, for instance, one-way spanning loads, two-way spanning loads, and even more complex arrangements where you might be subdividing down individual panels because of internal partitions on that cell. Furthermore, if you're looking at a steel frame, it's common to, of course, consider how your beams are cut and supported against your columns. So also in version 15, we incorporated what's called a rigid zone, and this helps you with that type of analysis. So for instance, in this model, you can cut your beams back against your column, and then you can just essentially use the design on the beam which is from the face of the column, and this is part of what we call rigid zones. So I'm now going to hand back to Julian, and he can develop the model further.
Okay, thanks Phil. So in this session we're going to look at constructing more of the geometry but with the engineering properties as well. So this is the geometry that we created in the first session. Now to start with, I'm going to go to the Layers tab, double click on Geometry, and I'm going to switch off the solid render on the surfaces. I'm then going to go to the Analysis tab, and I'm going to rename load case 1, and I'm going to call this Steel Dead Load. Okay, now when I created this, I'm going to switch on Gravity. When I created this model, I had some engineering properties already defined in the tree view. So if I click here, you'll see I've got some thick beam elements with 4 divisions. So I'm now going to select all the lines in the model, and I'm going to assign those thick beam elements. I also had some geometric sections. So here's the HE400 section that I'm going to use for the columns, and here's the IPE600 section that I'm going to use for the beams. So I'm going to look face onto the model, and I'm going to cross through the column sections, drag on the HE400 section, drag a box around here, drag on the IPE600 section. Now, I'm going to zoom in to this area here and look at the orientation of the columns. They're currently orientated in this direction. I want them orientated across the model. So I'm going to resize and look on the side again. I'm going to cross through the column members, and I'm going to drag back on my thick beam mesh, but this time put a beta angle of 90 degrees. This will reorientate the columns into the direction that I want. So if I look here now, you'll see the columns are in the direction I want. Now there is another problem here. If I look at this beam section, the beam section passes through the edge of the column, and I don't want that. So in the tree view here, I've got a thick beam element with 4 divisions, but I've got end conditions set on this, and I've set up the rigid links. So LUSAS will auto detect where the beam is going to pass through the column and insert a rigid link at that location. So what I want to do is OK that. I'm going to look down on the side of the model, and I'm going to select the beam members by crossing through them. So here, here, that one, and finally this one here. And I'm going to drag on my thick beam with rigid zones. Okay, so if I now look at my isometric view, I can zoom in and have a look at this section. And you can see the beam stops at the edge of the column. This one goes into the web. So that's exactly what I want. I can finish this model off now. So I'm going to select all the lines, and I'm going to drag on the material properties. Now, I'm not going to put the support conditions on until I've built the other floors of the building, but I am going to look at the floor loading. So here, I've already got a two-way spanning slab with two sub-beams and a load of 5 kilonewtons per metre. And I'm going to assign it to a single surface to start with, this one. So I'm going to put this into a load case called floor loading. So floor load, and OK that. And if I switch on the load visualization, I can then zoom in and have a look at the loading. Now if I open up the attributes tab again, so here you can see the two-way. So here I've got a two-way load distribution, and we've got two sub-beams. So two sub-beams, 1, 2. So this is setting up the floor loading for me for this particular model. So I can close that down. Now I want to apply this on all the surfaces. Now the simplest way of doing that is actually just to deassign it from that one panel to start with, and then pick all the surfaces. Now I'm going to deselect this surface and this surfaces because I want a slightly different orientation. But when I drag that load on into the floor loading case, you can see all the sub-beams and the loading distribution. I'm going to drag on the second floor load, and you'll see that I've got a slightly different sub-beam orientation for that place. I'm now going to switch off the load visualization, and what I'm going to do is pick the entire model, not quite, just pick it now, and I'm going to copy it in the Z direction by 6 meters. If I rotate this around, you'll see that I've got a 2-story frame now. Now it's only the bottom frame that I want to be 6 meters high. The next one I want to be 5 meters high. So I'm going to go look in the X direction. I'm going to select the top members here, and I'm going to move them by -1 in the Z direction, and that will give me a height of 5 meters. Once I've done that, I'm going to cross through everything to select it, and I'm going to copy that by 5 meters in the Z direction. So what this will give me is the first 3 floors of this building. So if I look at the isometric, you can see the frame that I've created there. Now at this point, I'm just going to select the points at the bottom of the model and put my pin supports onto the model. Now this frame that we're constructing here actually has a 10-story tower in the middle here. Now I could carry on working with this model, but a second engineer has already built that model for me. So I'm going to go to File, Open, and open up the top of the model. So here you can see I've got a model. Now this is used the layout grid at level 16. So we've already agreed where we're going to join the 2 models. So I can now go back to the original model. This is the one that I've just created. And I'm going to go to File, Model Merge, and I can select which second model I want to merge with first. I also want to merge the load cases. So there you can see I've ended up with a multi-story building from the 2 models that I've merged together. Just going to switch off that layout grid. And in the next session, we're going to take this on and look at the design. So at this point, I'm going to hand it back to Phil to discuss the design side of things.
Okay, thank you, Julian. We've had quite a few questions during those first 2 sessions. Because this is a relatively short webinar, for those of you that are seeking responses quickly, we're going to hold to the end of the event and pull a few questions of common interest. As I said, we will try and get back to people during the event as well, as we are able to do. Okay, so that now takes us on to the next part, which is really the focus of this presentation, and that's how we go about design. So the first side of this is creating design load combinations. This is a new utility as well within version 16, and really takes the sweat out of generating all the different permutations of permanent and variable load cases for you. So load cases within this are factored by type. Once you've described the type, LUSAS then deals with them according to the code of practice. This supports multiple codes, so again, North America, Europe, and various Asian codes are supported, and these will continue to be added to. Moving then on to the steel design. So first of all, you need to set up a steel design attribute. You'll see now in LUSAS version 16 that the menus have been somewhat rearranged. So on the attribute menu, you now have both concrete and steel design attributes. The dialog on the screen is the steel design one, within which I set up things like end conditions for my effective length calculation, and I can use this to group my members into like members that I'm likely to be applying the same section size to. Once I've done this, I then define and assign that to the model in the same way as I do for any other attribute within LUSAS. Moving then on to the results, once we've run the design calculation to our variety of codes of practice, we can get out of this utilization ratios and see the results information in a variety of ways. So whether you just want to see summary information in terms of utilization contour plots on the screen, that's fine. But if you want to go further forward as well and see every single step of the calculation for a single member or for a critical member within a group of members, then you can also do that. Anything you create can be added to the report. Any changes to the model will automatically update that report. Steel design code supported at the moment. We have the North American AASHTO code, that's a bridge code. The subject matter of today is the Eurocode buildings code. We have other codes, as I said, coming through, including the Eurocode bridge code, and then also at the moment Canadian highway and the Australian building standards. So at that point, I'm going to hand back to Julian and we can go through the steel design on this multi-story building. Okay, Julian, over to you.
Okay, thanks, Phil. So what we're going to look at in this session is design. But before I talk about design, I'm going to talk about the loading that I've got on this model. Now, in this model, the one that we built in the last session, we've only got two simple load cases, steel dead load and floor loading. In reality, I would have other loading such as wind on here, but for this presentation, I'm just keeping it simple. But what I do want to do is create some design combinations. So design combinations. Now I'm going to look at the EU1990 buildings, and I'm going to set the steel dead load as permanent and the floor loading as imposed. Next, I'm going to look at the fundamental combination. And for this example, I'm not going to create an envelope of the combinations. So there are my combinations that I've created. If I click on one of them, you'll see the factors that have been placed into the load cases. I'm going to save the model and I'm going to solve it. Once it's been solved, I can start to look at the results. So I'm going to look at contours of force moment Fx, the axial load on these members. So there's the axial load that I'm seeing on the screen. Now that's for the floor loading. I'm going to set active this combination here because that should be the worst. So I'm now looking at the axial load for the combination. Now, rather than looking at axial load for a combination, I want to do some steel design on this. So to do that, I'm going to go to the design menu, steel frame, and I'm going to choose which design code I'm going to work with. So I'm going to work with EN1993. And these are the default values that I'm going to work with today. Now, once I've done that, I can create some design attributes. So attributes, design, steel frame. Now, this is the EU steel design attributes. Now, on the top left-hand corner, you set the grades of steel that you're working with. Top right-hand corner, the actual tension of 0.6 is a bit low. I'm going to set that as 0.8. And now I'm going to talk about the restraint. So this column here, I'm going to assume is unrestrained. So I'm going to leave that as unrestrained and call this design column and hit apply. Now the beam members I'm assuming are being restrained by the concrete slab on their top flange. So top flange restrained, and I'm going to call this design beam. Okay, so these two attributes now need to be put onto the model. The simplest way of doing this is go to the geometric section here, right-hand mouse button, select assignments. That's picked all the columns. I'm going to drag on the column, and I'm going to repeat that with the beam. So select assignments, say yes, and then drag on the beam design section. Okay, now I've done that, I can go to the layers and double click on my contours layer. And rather than just look at force and moment, I have the steel frame entity. I can choose that and then choose which of the design checks I want to look at. To start with, I'm going to look at compression. So if I OK that, rather than looking at axial load, I will get a utilization on the compression check. And you can see the maximum utilization is 0.98. If I zoom in here, it's one of the lower columns down here that's going to have that maximum utilization. I'm going to select that line and I'm going to do a member report on that line. So what this will show me is the steel design calculation. So here you can see it's passed up there. If I scroll down through, I can see all the calculations and what numbers are being done. Now here, if I scroll down through all the checks, you'll notice some of them are red, they failed. And that's because the compression utilization was so high that when we start to look at compression and bending, it's going to fail. So we know that's failed. Again, I can look at the calculations to see why it's failed. But in this case, I know that the section that I've used for the columns is quite light, so I need to make that a heavier section. However, before I change this section, what I'm going to do is change the contour I'm looking at. So contours. Now, rather than look at an individual check, I'm going to do the util max. This will show me the worst of all the checks, so I get a very good idea of which one's failing. I'm also going to set the maximum value to 1. Therefore, anything that is shown is red, I know is failing one of the checks. So here you can see the maximum utilization I've got is 2.4. So lots of red. So what I'm going to do now is increase the section size. So I'm going to go to my column and change to a 400M section. Now I'm doing this without rerunning to start with, because I can check to see how that affects the utilization. It's now below 1. Once I've checked that it's sensible, if I want, I can rerun and get an accurate calculation on the forces and moments. So I'm just going to set active the combination. So there you can see it's very little difference in actually rerunning the calculations. Now, what we've tried to do today is just give you an idea of how this works. I'm just going to select this line again and do a member report again. Now these member reports, you can see everything's now passing. I can print them out or I can add them into the LUSAS report for further printing. Now in this session today, we've gone quite quickly. If you want to find out more information, what I'm looking at now is the detailed example that comes on the example kit. It has more loading, it talks about restraint in different directions, and it's a very good place to start to learn more detail about the frame designer that we haven't covered today. So hopefully you found this presentation interesting. If you want more information, look at the examples. But at this point, I'm going to hand it back to Phil.
Okay, thank you, Julian. You can give your voice a break now. Probably much needed. Okay, so that completes the technical side of the presentation. Let's talk about what other content will be made available to you in terms of steel design in version 16. We had to choose a code of practice, obviously, for this presentation. We chose the Eurocode. We could have chosen the 3 others as well. What we have, or will shortly do, is load up onto our website a steel truss to the AASHTO LRFD code. Everybody that's attended this presentation will get the link for that, so then you can see the comparison between the two. The workflow is identical, of course, but if you want to see something that's in the context of your units, of course, working in the States and imperial units, and relates to your codes of practice, then you'll have that for reference as well. Okay, we're going to move forward to some question and answers now. Julian's not had much time to look at this. Many people were asking about the speed of the presentation. Would they be able to see a more detailed example? Julian has pointed you at the example within the program. For those of you that aren't users, I think what we can do is we can put up the example as a PDF that everybody can see, whether you're users or not, just to give you an idea of how the Steel Designer works. Julian, do you see any other questions in there that...
Yeah, we've got a question here about the layout grids. Is it possible to import layout grids from DXF files? At the moment it isn't, but it is something that we are looking into, so effectively. But what you could obviously do is, rather than create the geometry frame inside LUSAS, you could create that in the CAD system and import the whole frame rather than using the layout grids.
Okay, thank you, Julian. We've got quite a few questions on codes. I'm going to come to that in a moment, actually. So let's not do that. Got another question here on general design, which Julian is having a quick look at.
We've got a question here about column buckling lengths and whether they can be entered directly. I think at the moment you can do that, but I would need to check that, and so we'll get back to you individually on that.
Okay. And with other questions, we'll come back to you separately, obviously, after the event, as we said to you earlier on. So that's version 16. Obviously, we're always looking forward. Version 17 will be the new release. It's probably worth explaining at this point, particularly for those of you that know us, that we're changing at the moment the way we release product. We're doing it more regularly. I think that's good news for everybody. So version 16 came to the market in, Julian, about early December, was it, I think? Yep. Or sort of late November, early December last year. And we're looking at getting the version 17 release out around the sort of April time frame this year. So we're very much on target. We have this fully functioning. Technically, it's going through its testing and other internal processes at the moment. But one of the great things for it, obviously, according to the Eurocode, is that it supplements what you've just seen, which is the building code, with the bridge code. And we have a very big position, obviously, in bridge infrastructure, particularly in the UK. So I'm sure many of those watching from the UK will be very happy to see that coming in. It's probably worth saying that it is complete. We can show it. So if there are those of you that are watching it that really would like to see it now, how it functions, and some proof that it's very much on its way, please do get in contact. We are currently presenting it to clients when we go in and visit them. So that's version 17. There are many other things in version 17 as well, but you'll get notification of that latterly. So just to remind you, the Steel Designer of version 16 is a new option. If you do want to upgrade, please come back to us. We've got a half-price offer on at the moment until the end of next month. If you see the need to use this in that time, please get back to us and we'll be very happy to upgrade you. Also look to our version 16 microsite. We released this with the version 16 software in December last year. So you'll find on there everything that's purely related to version 16 if you want to be clear on what the difference is between that and the pre-existent core product. You'll also see in there now a joining of all of our various blogs and social media aspects. So whether you're following Facebook, YouTube, many of you follow us on LinkedIn, particularly amongst our client base, you can see all of those posts now joined on our microsite. If anybody needs help, well, we're here to obviously to answer some of the questions that have come from the webinar. I would say following the webinar, do remember our support team. We get great response from our user base on the quality of support that they offer. So whether you want to ask us about the steel design content we presented today or content that's more general, please do take advantage of the support service. And that's all from us. So I'd say thank you. Thanks very much for your time.
Thank you for your time.
And we look forward to seeing you at an event again in the near future. Thank you and goodbye for now.